Okay, so there's three things that we need to think about with fractions. Um, One is to think about fractions that have fractions within them. Another is to think about common factors. This is a way that we can often simplify fractions. And we sometimes need to worry about common denominators when we're trying to add or subtract fractions that don't have the same number in the bottom part. So let's just, to get started, remind ourselves that if we have a fraction a over b, the denominator is what's down below, and the numerator is what's up here. Okay, we're going to be using those terms a little bit here. All right, so fractions within fractions. We have something like a over b divided by c over d. Okay, when we have a fraction in the denominator here, that is the same thing as having its reciprocal in the numerator. So let's actually put that one last little piece of lingo in here as well. Our vocabulary terms for fractions unit is numerator, the top part, denominator, the bottom part, and the third one is reciprocal, is when we switch the numerator and denominator. We turn that fraction upside down. Okay. So in this case, it would be b over a. It's the reciprocal. So when we have fractions of fractions, when we have a fraction in the numerator, it's just a fraction. We have a fraction in the denominator, it's like having that reciprocal in the numerator. So fine, just to resolve that, that's the same thing as a over b times d over c. So that's what I did. I had c over d downstairs, and I brought it up to sort of the numerator. If it's not a fraction, it's like a fraction with a denominator of 1, so it's just a numerator. And that's how we get rid of the messy nested fraction in the denominator. Another way to think about this is that fractions are a way of representing division. So when we've got c over d in the denominator, it says we're dividing by c over d. That is the same thing as multiplying by its reciprocal. So thinking about how that works with numbers, if we have something like 5 divided by 1/2, that is the same thing as 5 times 2 equals 10. So really pretty straightforward. Similarly, common factors, also pretty straightforward. If we have a fraction like 63 divided by 49, we might notice that 63 is 9 times 7 and 49 is 7 times 7. And look, what we have here, this 7 times 7, this is like multiplying 9/7 by 1. Okay, so again, I'm using those sort of basic rules of algebra that lets me regroup all of these products any way I want. So instead of thinking about 9 times 7 divided by 7 times 7, I can think about 9 over 7 multiplied by 7 over 7, which is 1, and that gives me 9/7. So just writing out those steps here, that is the same as 9 over 7 times 7 over 7, 9 over 7 times 1 equals 9/7. I think many of you are already familiar enough with common factors that you would just go right from 63/49 to 9/7 without batting an eye. But all these steps here are steps that are justified by those basic rules of algebra. Okay. Common denominators are take a little bit more work. So what does that even mean? We think about common denominators when we are adding or subtracting fractions. Apparently this word is too hard for me to spell while I'm talking. Denominator. Okay, We have common denominators. Yes. Like I said, if we have two fractions that we want to add or subtract, they need to be over a common denominator. So what does that mean? It means that they have to have the same denominator. So if we are starting with a plus b, a over b plus c over b, no problem. There's already a common denominator. They have the same denominator, so we just switch that to a plus c over b. Distributive law at work here. Where it gets trickier is if we have something like a over b plus c over d. So b and d are not necessarily the same number. All right, so one thing that will always work, and we'll do this kind of systematically, is if we multiply both expressions here in this sum, the a over b and the c over d, we're going to multiply them both by 1, but it's going to be 1 in a special form. We're going to multiply a over b times 1 in the form of d over d. And we're going to multiply c over d times 1 in the form of b over b. So we're using that basic rule of algebra. We're multiplying things by 1 and rewriting that. So we get AD over BD plus CB over DB. Now, we do have a common denominator here, and so we can just add the numerators. AD plus CB over the common denominator BD. All right. So let's do that with some numbers. So let's say we have 5/6 plus 1/4. We want to add those things, and 6 and 4 are different denominators, right? The product of the two denominators will always be a common denominator. It will always work. Okay, so it's no problem with just saying, okay, well, I'm going to multiply 5/6 by 4 over 4 and 1/4 by 6 over 6, and I will get 20 24ths plus 6 24ths is 26 24ths. Okay. Then looking at that, thinking about what we just talked about with common factors, I might notice that both of these they're both even numbers. So I can divide out a 2 and I get 13 12ths. Perfectly fine way of doing things, might be the fastest way of doing it. Another perfectly fine way that will work would be, so another way to the same thing, would be to notice that 12 is also a common denominator here. We could put these over the common denominator of 12 if we multiplied 5/6 by 2 over 2 and 1/4 by 3 over 3. Okay, the lowest common denominator, the smallest number that has both 6 and 4 as a factor is 12. When you think about identifying the lowest common denominator, we noticed here that it's 12. Then to put the expression over a common denominator, we just think about, well, what do I need to multiply 6 by to get 12? 2. What do I need to multiply 4 by to get 12? 3. Those gives me the forms of 1 that I use here. Long-winded justification. Let's just convince ourselves that that does indeed give us the same answer. We get 10 12ths plus 13. Sorry, we don't get 13 yet. 10 12ths plus 3 12ths. We multiply 3 times 1 and 4 times 3, we get 3 12ths, but we do indeed end up with 13 12ths. Okay. So the important thing when we're adding or subtracting fractions is that they be over the common denominator, and any common denominator will work. If you pick the smallest one, you'll often be able to skip a simplification step later, but it's no big deal. It didn't really cause us any damage to reduce 26 24ths, 13 12ths at the end. here. So the next video has a few more examples of simplifying fractions using some of these techniques. So check it out.